Hello students, welcome back to Chem Try. Now today we are talking about balancing redox equations or reactions in acidic medium. Balancing redox reactions in acidic medium. When you are asked to balance redox reaction in acidic medium, how do you go about it? We have these 9 steps to follow. Now they might seem so many, but trust me, if you try solving questions with these steps, when you solve 1, 2, by the time you get to the 3rd question, you should be okay with the steps. So don't worry about the number of steps you have to go through. It's very easy. Now, in the first step, we determine the oxidation numbers of all the atoms in the equation. And to do that, we need to have the rules for assigning oxidation numbers at our fingertips. Now, we also want to figure out what is oxidized and what is reduced in the chemical equation. Then, we will write the half equations, then balance all atoms except oxygen and hydrogen. We then add water to balance oxygen and hydrogen ions to balance hydrogen. To balance the charges, we add electrons. Then we also multiply the half equations by a factor or by factors that will make the number of electrons equal in both half equations. We would also add the half equations together and cancel out things that appear on both sides and do a final check to see that everything, atoms and charges, are all balanced. We will check that one as well. So let's talk about this example. Balance Cl2O7 minus plus Cl minus going to produce Cl3 plus Cl2 in acidic medium. We'll be looking at how we use these 9 steps to balance this chemical equation, this redox equation in acidic medium. Now the first thing we do is we write down the chemical equation. And figure out which of the species is undergoing oxidation and which one is undergoing reduction. But to do that, the first step says that we have to determine the oxidation numbers of all atoms in the equation. Now, oxygen, we said, apart from being in peroxides, has oxidation number of -2. So we have -2 here, and we have 7 of them. So -2 times 7, and that will give us -14. We don't know the oxidation number for chromium, so we represent it with X, and we have 2 of them, so we have 2X. Now, this is a complex ion, different atoms combined, and it is still charged. So when we add the oxidation numbers of individual atoms over here together, we are supposed to get the charge carried by the whole complex ion, which is -2. So this will give us 2x is equal to 12, and x will be equal to +6. So chromium has a charge of +6 over here. Chloride ion is a simple ion. And what did we say about simple ions? The oxidation number is equal to their charge, which is -1 over here. Chromium ion over here is also a simple ion, so its oxidation number is equal to its charge. Chlorine gas is standing there all alone, chlorine element uncombined with other elements, so its oxidation number is 0. So that is the first step, determining the oxidation numbers of all the atoms or all the elements in the equation. Now, for the second step, we are supposed to figure out what is oxidized and what is reduced. And the oxidation numbers will help us to do that. Now you can see that oxygen has its oxidation number as -2, but we don't have oxygen here, right? So we will ignore that one for now. Now chromium has an oxidation number of +6. which then decreases to positive 3. That means chromium is undergoing reduction. Now we have chloride ion. The charge is -1 and it increases to 0. So chloride ion is undergoing oxidation. So now we've seen which one is undergoing reduction and which one is undergoing oxidation. So step 2 is done. Step 3, write the half equations. Now the half equations we said talks about only the half, or talks about half of the whole story, not the complete story. So it will either talk about only the reduction or only the oxidation. So let's write the oxidation half reaction. Now it is chloride ion going to produce chlorine gas like this. That is the oxidation half reaction. Then the reduction half reaction. The reduction half reaction is Cr2O7 2- going to produce Cr3+. Let's talk about step 4. We are supposed to balance all atoms with the exception of oxygen and hydrogen. Now, let's look at the oxidation half reaction. We have 2 atoms of chlorine here, and we have only 1 over here. So how do we balance it? Our oxidation half reaction, we put 2 here to make the chlorine 2 at this side and 2 chlorine atoms at that side. So the chlorine is now balanced. Then with the reduction, we have Cr2O7 2- going to produce Cr3+. Now over here we have 2 Crs over here. So we put 2 there. The Crs are balanced. Now remember, we said balance all atoms except oxygen and hydrogen. So we balance the Cr3+. We are seeing oxygen here, but we are going to leave it for a while. Next step, we'll talk about it. Now, the next step in step 5, add water to balance oxygen. Now we have oxygen over here. So to balance the oxygen, we will add water to the product side, not the reactant side, the product side. So we have Cr2O7 2- going to produce 2Cr3+. Now we will add water to this side to balance the oxygen. But the oxygen atoms are 7 over here, and when we added the water came with only 1 oxygen atom. So how are we going to make sure the oxygens are balanced? Okay, we can put 7 here to make the oxygen atoms 7 over here at the product side and 7 over here at the reactant side. So the oxygen atoms are now balanced. We are also supposed to balance hydrogens because we have 14 hydrogen atoms over here. But how do we balance the hydrogens? By adding hydrogen ions. So we have the water here. The hydrogens are over here, but there are no hydrogens over here. So we are going to add hydrogen ions to this side to balance the hydrogens. So plus hydrogen ion. And we have 14 hydrogen atoms here. So we have to put 14 here. So now the hydrogens are balanced, the oxygen atoms are also balanced, and step 5 is done. Step 6, we are going to balance charges. How do we balance charges? We balance charges by adding electrons. Now remember, electrons are negatively charged. And to balance charges, we have to first calculate the oxidation numbers at the reactant side and at the product side of each half reaction. So let's first take the oxidation half half reaction, which is 2Cl minus going to produce Cl2. Now over here, the oxidation number of chlorine here. Now chlorine is an ion here, a chloride ion, and it is a simple ion. So the charge will be equal to the oxidation number will be equal to the charge carried out by the single ion. Now the charge is -1, and we have 2 atoms of chloride ions. So it will have a total charge of -2. This is chlorine gas, an element standing there alone. So its oxidation number is 0. Now when you look at it critically, that means we having -2 charge here tells us that we have excess electrons here. 2 excess electrons here at the reactant side. So to balance the charges, we are going to add 2 electrons to this side, so that the electrons over here will become -2. The charge will be -2, which means we have 2 excess electrons, and here too we will have 2 electrons. So the charges will be balanced. The charges will be balanced. Now let's look at the reduction half equation. There we have 14 hydrogen ions plus Cl2O7 2 minus going to produce 2Cl3 plus 7 moles of water. Now, each hydrogen ion carries a +1 charge, and we have 14 of it. So we have +14 charge over here. Over here, this is a complex ion. So the sum of the oxidation numbers of the various atoms in a complex ion will all be equal to the charge carried out by the simple ion. And the charge carried by the simple ion is -2. Sorry, -2. Now, the product side, you realize each chromium ion has a charge of +3, and we have 2 of the chromium ions. So 2 times the +3 will give us a total charge of +6. Then water is a neutral compound. So when we add oxidation numbers of the individual atoms over there, we are going to get 0. Looking at it critically, we can see that at the reactant side, the total charge will be +14 plus -2, which will give us +12. At the product side, the total charge will be +6 plus 0, which is equal to +6. So the total charge at the reactant side is +12, and at the product side is +6, telling us that to balance the charges, we need to add 6 electrons here. When we add 6 electrons, the 6 electrons will cancel out 6 of the positive charges, leaving behind 6 of the positive charges. Now the charge over here, the total charge over here, becomes equal to the total charge over there. I'm taking the balancing of the charges once again. With the oxidation half equation, chloride ion has a charge of -1, and we have 2 of the chloride ions. So the total charge will be -1 times 2. The total charge at the reactant side now becomes -2. At the product side, we have chlorine standing there all alone, and it is not charged. So its oxidation number is 0. This means that the reactant has a -2 charge, and the product side has 0 charge. Now, to balance the charges, we can add 2 electrons here. Now remember, electrons are negatively charged. So when we add 2 electrons over here, this part will end up having a net charge of -2, which is the same as the net charge at the reactant side. Looking at the reduction half equation, hydrogen ion each one has a +1 charge, and we have 14 of them. So 14 times +1 will give us +14. Now, Cl2O7 2- is a complex ion. So if we are to add the oxidation number of chromium to that of oxygen, we are supposed to get a -2. So the total charge over here is -2. At the product side, this is a simple ion, so its charge is +3, and we have 2 of them. So the total charge over here will be 2 times +3, which will give us +6. This H2O is a compound, and the total charge of a compound is 0. Now, when you add them together, you realize the product side will have a total charge of +6. +6 plus 0, +6. And the reactant side, +14 plus -2. That will give us +12. Now, this part has 6 plus 6. This part has +12. So to make them the same, we have to subtract 6 from this side. And how do we subtract? By adding electrons. Now, each electron carries a -1 charge. So to balance it, we will add 6 electrons to this side, the reactant side. When we add 6 electrons, the 6 electrons will reduce the number of charges, that is +12 to +6, which becomes the same as the charge on the product side. So that is how we balance the charges. Now, in the next step, we are supposed to multiply the half reactions by factors that will make the number of electrons equal in both sides. Now, remember, in the reduction half reaction, we have 6 electrons. In the oxidation half reaction, we have 2 electrons. So to make them the same, we can multiply the oxidation half reaction by 3. So oxidation half reaction by 3, and that one will give us 6 chloride ions going to produce 3 chlorine gas plus 6 electrons. Now you realize the electrons over here and there are the same. So we move on to the next step. We will add the half equations and cancel out things that appear on both sides of the equation. So we will add the oxidation half reaction over here to the reduction half equation. So let's add the oxidation half equation, which is 6Cl minus going to produce 3Cl2 plus 6 electrons. Let's add that one to the reduction half equation, which is 6 electrons plus 14 hydrogen ions plus Cr2O7 2- going to produce 2Cr3 plus 7H2O. Now, when we add them together, at the reactant side, we will have 6 chloride ions plus 6 electrons plus 14 hydrogen ions plus Cr2O7 2- going to produce 3 Cl2 plus 6 electrons plus 2Cr3 plus 7 moles of water. Now, do we see something that is common on both sides of the equation? Yes, we have 6 electrons here, 6 electrons here. So the electrons cancel out. Then we will have 6Cl minus plus 14H plus Cr2O7 2- going to produce 3Cl2 plus 2Cr3 plus 7H2O. Now we have to, from the last step, do a final check. Do a final check to see if everything, that is atoms and charges, are balanced. So let's go and check the atoms first. After that, we check the charges, okay? Now, the atoms here we have chlorine, hydrogen, Cr, On the product side, we have chlorine, hydrogen, Cr, and O. Now, chlorine over here is 6, hydrogen ions is 14, Cr is 2, and oxygen is 7. On the product side, Cl is 3 times 2, which is 6. Hydrogen is 7 times 2, 14. Cr is 2. Then oxygen is 7 times 1, which is 7. So the atoms are balanced. Now, let's check the charges and see if the charges are also balanced. Now, over here, we have Cl minus having a charge of -1, and we have 6 of them, so -6. We have H plus having a charge of +1, and we have 14 of them, so +14. Then Cl2O7, its whole charge is -2. Over here, it's an element standing there alone, so its charge is 0. Cr3 plus has a charge of +3, and we have 2 of them, so +6. And this is a compound, so its oxidation number is what? 0. When we add everything together, we are going to get 0. So over here we have -6 plus 14, that will give us +8. -2, so the total charge over here becomes +6. And over here we have 0 plus 6 plus 0. That one too is +6. So the charges are also balanced. In balancing redox reactions, we balance not only the atoms, but we also balance the charges. So after everything, check to see if the atoms are balanced. Not only the atoms, also check to see the charges are also balanced. I'll give you an assignment which you would try your hands on. Now, try balancing this equation in acidic medium. Try balancing this in acidic medium, and let's see if you are going to get it right. Thank you.